second. Okay, so 6.1 and 6 point what is that? 6.3 kind of overlap on this section here. So reference angle we've talked about quite a bit already. So I might have one question on that, or it might be part of another question. So reference angle of -45. So that means you're going to go down here 45 degrees. So the distance from here to the x-axis is 45. So reference is 45. Right now, coterminal means any angle that will get you to that same spot. So I'm already here. So I can add 360 to -45 and go all the way around and land here again, which would be 315. So you can either just write that number down, find a location -45, there's my coterminal, or add 360. Either way, reference is just the distance, always positive. Coterminal is -45. The easiest way to find it is just add 360 to it, which is 315. Angle in radians just convert it to radians by multiplying by your conversion factor times pi over 180. So multiply this out, you get -45 degrees pi over 180, which reduces to -pi over 4. So 6.1, that's almost one of the main things that they talk about there. But they also mention it again in 6.3 or 6.2. Any questions on example 1? Okay. The last thing I'll ask about 6.1 would be something like this. Find the arc length. And the area of the sector. So I'll probably just give you some numbers, but on this question, I'm going to give you a picture. So this angle right here is about 80 degrees. The radius is about 8. So we'll say R is 8. Theta is 80 degrees. Okay. Now we said in order to find the arc length and the area, you need to have it in radians. So you got to change this guy. So multiply 80 degrees by pi over 180, like we did earlier. That will get us to 80 pi over 180, which reduces to 4 pi over 9, right? So now that we have the radius and angle, we can just use these formulas. Arc length is S equal to R times theta. So just multiply them and you'll be good. So 8 times 4 pi over 9. That's your arc length, which is what? 80 times 4? 32. Yeah. Okay. Area is 1/2 times your radius squared times your angle in radians. Has to be radians. So 1/2 times 8 squared times 4 pi over 9. So that will be 8 squared is 64. Half times 4 is 2. 64 times 2 is 128, right? Yeah. So there is my surface arc length and area. So that's all I'm going to ask about 6-1. I'm not going to ask about the linear speed type stuff. Okay. Although notice how in example 1 we did some conversion, so I might not ask you outright. I might just leave it in a question like this. So it's you still need to know it, but it's in the background. Any question on example 2? You guys cool on this page? We'll move on to 6-2 after this. Yeah.
When I multiply 4 pi over 9 times 8, 25.
8 squared?
Oh,
Or which
no,
one?
before that, step before that. Yeah, that one.
This one? 8 times 4. You put 9 on the bottom?
Yeah.
8 times 4 is what?
32.
32. And it's not going to reduce with 9, so it should be 32. Double check the input. Like this?
Yeah.
True.
I put 80, that's it.
Oh, okay. Gotcha. I don't have enough space here. You guys cool on that page? Find arc length and area. Give them given a radius of 5 meters and a theta, an angle of, let's say, 20 degrees. Not sure how I'll phrase it later, but basically this will all be same, something like this.
Is it 0.5 or 5?
Just 5 meters. So you have to just write down R and then change your theta into radians. So multiply this guy by pi over 180, and you should be good. Okay, so the 10 powers of 10 would cancel. I'd be left with 2 over 18 pi over 9. This would be the radian for 20 degrees, pi over 9. So just plug it in, you'll be good. X would be equal to r theta. That'll be 5 meters times pi over 9. That gives us 5 pi 9th meters. If you want approximation, you need a calculator. So about 1.75 meters. Area is equal to 1/2 r squared theta, which will be 1/2 times 5 meters squared times pi over 9. So 25 over 2 times pi over 9, that'll be 25 pi over 18 meters squared. 5 squared, that's that.
Question,
Yeah, that's it.
why was it the 18th at the bottom?
One more time.
Why was the 18th at the bottom?
This one?
No, the last.
Oh, 2 times 9. Multiply the fractions.
Okay, so did we do the exact same thing on the last one?
Yeah. On the last one, the 1/2 cancels the 2. Or the 4 rather. The 1/2 times that 4 is a 2. 2 times 8 squared is 128.
Right, but we didn't change the bottom one.
Back as they cancel with the 4. That makes sense? Or? I mean, I could, but it'll reduce anyway. Like you could do 18, but then it'll be reduced by the top anyway. So you could do it reduce now or later. It's not going to matter. As long as you reduce, you'll be good. Yeah, I didn't show too much of the fractions. Okay. Any other questions on number 3? .36 meters squared. Move on to 6.2 now. Find the 6 trig functions. Given cosine theta equal to 12 over 13. So I need to find sine. They gave us cosine, tangent, and then I like to put the reciprocals right underneath. That way you can just flip them over. Reciprocal of sine is cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. Okay, so technically I have this answer, right? So to answer the rest, you must solve for the opposite side. If I choose to put theta here, based on cosine, we have adjacent and hypotenuse. So solve for this missing side, and then you can answer all of these cases, right? Okay. So Pythagorean theorem, let's call this A, I guess. It'd be 12 squared. If I want to solve for B, plug in the hypotenuse, subtract the 12 squared over. What is going to be B?
But so it'd still be positive 12 even though you move it over?
I don't know why I did that. What's up? One more time.
Or it'd still be positive 12 even though you move it over?
Yeah, it should be minus. Yeah, something. Thanks. Yeah, I just noticed something's wrong here. There we go. There should be 5. It's one of the magic triangles. All right, so sine will be 5 over 13, which means that this would be the reciprocal. Tangent would be opposite over adjacent. And cotangent is reciprocal. And that's it. That's, oh, yeah. It's the main thing I'll ask from 6.2 other than word problems. Any questions on this before we do a word problem? Oh, wait a minute. That's cool on this page. Example 3 or 4, I think. Still 6.2. I'll just pull this out of the homework. I'm going to try to pick a nice question. So distance at C. So from the top of a 200-foot lighthouse. So from the top the angle of depression to a ship in the ocean is 23 degrees. How far is the ship from the base of the lighthouse?
Does that say the angle of depression?
Yeah. And I'm going to make a note of what that means in just a moment. So from the top of a 200-foot lighthouse, the angle of depression to a ship in the ocean is 23 degrees. How far is a ship from the base of the lighthouse? Okay, so I don't remember if I mentioned the difference between elevation and depression. So quick note. visually, right? Depression angle, not emotional state. I'm not going to draw that visual for you. Depression angle is going to be more like, so if I'm looking straight across, right? Let's see here. There's some object over here. This is the depression angle. That makes sense. So you're looking straight, and then you look downward. So that angle formed. Elevation angle would be if you're looking up, let's say you're on the ground, and you look up at some object, that would be the angle formed going upward, okay? So in this example, let's draw our lighthouse, I guess. Don't think I can draw that, but here's some rectangle. Okay, so you're on top of the lighthouse. Light haunted or something. You're looking straight across, and then you look down at some ship. The ship, we'll say, is over here somewhere in the water. So the angle of depression is right here. Okay, so that's 23 degrees. They want to find the distance from the base of the lighthouse. So from here to here, they want to know the distance. So how far is the ship from the lighthouse, from the base? So just across. Okay. I know the height of the lighthouse is 200, right? You got that information. Can you find this angle here? What is the angle? Yeah. 90 minus 23, that's 67. Okay. So now you got to choose your trig function that incorporates d and a known side, not the hypotenuse, because that's unknown. You do not want to use something that has two unknowns. So what trig function would you choose, assuming this is the theta? Here. Yeah, tangent would be opposite over adjacent. The tangent would be the best, and it also would be on top, so it's even better. Cotangent would have also worked, but this one I think is better. Sine and cosine would not work because they need a hypotenuse. We can't find it. Not until we get the distance. So tangent of 67 is opposite over adjacent.
Question.
Yeah.
Okay, so you turned 200 to degrees now?
Well, I don't know why I did that. Sorry. Should be feet, right? Not degrees. Okay. So 200 feet times tangent of 67 will give me the distance by multiplying both sides by 200. What is the distance?
471.17.
That sounds right. Also sounds reasonable, right? The tower's 100 feet tall, 470 feet away. It does not sound ridiculous. If this would have been like 7 feet, then I'd probably start to wonder that it's probably wrong. Or if it was like 20,000 feet, I start to wonder, can I see that far? Yeah.
These 67 came from?
So if I'm looking straight across and then I have a depression angle, That's gonna be 23, but the angle formed, this right here is a 90-degree angle from looking straight. So you can subtract from 90 to find the 67. Because I want to use this triangle in here to solve for D. I don't want to build another triangle using 23 because I don't have any info. Yeah, I guess I mean, maybe you could think about this. If I were to build a new triangle, this is technically be 200, right? So you could, I suppose, and do like I want to find this distance, which would be the same as this distance. The tangent of 23 would be this over that. You could go that route if you wanted to, but I think that's a little more confusing. But anyway, does this make sense? The setup is what matters. This part right here, just basic algebra. What I need to know is, can you build this diagram? Can you set it up? You see where all these numbers came from. Good. I did skip an algebra step here, but so let me know if that bothered you. I think that's all I'm gonna ask about 6.2. 6.3, I kind of already mentioned. I think during the review Monday, we said the only thing I cared about was reference angles, which I already talked about at 6.1, I think. So one extra thing, I suppose, I might put in something like this: find all 6 trig functions. So similar to the other question we did, which is more complicated. Given that tangent theta is equal to 4/3, and theta is in quadrant 3. So quadrant 3 is over here, right? Do you agree that x and y are both negative? So that means that cosine is negative, sine is negative. Tangent is defined as sine over cosine. So negative divided by negative would be positive. So do you see why tangent is positive here when it's in quadrant 3? This should also tell you that when you find cosine and sine, that they better be negative. Like, don't make them positive.
Now, let me do quadrant 1.
Quadrant 1 tangent will also be positive. So given just this would not be enough information to give the correct answer. You gotta be given the quadrant or something else. Okay, so let's build our triangle.
I have a question.
Yeah.
Can we do like tan inverse 4/3, and then we'll find the angle and just like cosine the angle, sine the angle, and that'll be all?
You could, but I'm going to tell you to give me exact values. So you would have to give me no decimals. So your calculator would not give you any exact numbers unless it's an easy angle, like a known angle. But technically, yes, you're right. Opposite over adjacent, right? This one, magic triangle, so that should be a 5, 3, 4, 5.
What kind of
But
triangle is this?
magic. It's so there's a few triangles that keep coming up that give you full numbers for all 3 sides. There's like a few of them. Yeah.
If it was in quadrant like 2 or whatever quadrant, the numbers would correspond to.
Yeah. If this was quadrant 2, then 4 would be positive, but this would be negative. So yeah, so keep that in mind that when you see this information, look at the circle. So now that we have everything and we know which ones are positive and negative, we know sine has to be negative, right? Cosine has to be negative. Tangent is given to us. So the pairs right there. Now reciprocals, cosecant is also negative. It's just a reciprocal. Doesn't change the sign. Secant, also negative. Cotan is a reciprocal, so it would be positive. Once you build a triangle and you put the correct sign, it should come right out. Okay. So that's pretty much all for 6.3. 6.3 talked about reference, angles, and had questions like this in there, which are very similar to stuff in 6.2. It's just slightly more challenging. They incorporate the signs. Okay. Any questions on this one? Example 5. Oh, sorry.
How come 10 is positive?
Because you're going to divide negative by negative,
Oh,
so it turns it into positive. That's cool on this page. That's 6. So the right triangle. So 6.4 was where they gave you a set of triangles and you have to solve what was missing, but it was just basic right triangles. It wasn't anything crazy. Once we stopped using right triangles, we had to do log sines, log cosines. So on this one, it should be an easier type. Okay. This is all they give us, 4, 7, and right angle. The first thing we should do, well, we can find theta, right? By doing an inverse sine. Because we have opposite over hypotenuse. So might as well just find the theta first. So we can say that sine theta is equal to 4 over 7. Sine inverse of both sides. 4 over 7 would be theta equal to, whatever that is, let me see. So about 34.9, that's right, 85. So that's theta. Let me make this bigger. So theta we found to be 34.85 degrees. We were given an opposite side and a hypotenuse. I don't know what this is. This is 90. But since we have two angles, we should be able to find that one, right? Well, what is this angle? Let's call it theta, I guess. Yeah, so let's just subtract right from 180. You guys get it? 55 point what? 55.15. All right, so we got almost everything. Now we just need that side. Right. Well, we're just gonna do just Pythagorean theorem. That's about all we can do. So a squared plus b squared is equal to c squared. A is 4. C is 7. So b will equal 7 squared minus 4 squared. So b is the square root of 49 minus 16. It's 30. Yeah, thanks. 33. So we got all the sides. So whenever you have a right angle, remember you don't have to do log sines and all that stuff. Okay. So don't start doing that. I mean, it might still work out if you mess that up, but don't do extra work if you don't have to. Any questions on example 6?
Next example.
Yeah.
We're at 6.4.
Still 6.1. Got this from your homework. Rewrite the expression. So sine of tangent inverse of x.
So with on the last problem, if it had been on the test, would you have accepted adjustment? For the sine. Instead of the square root of 33, would you accept 5.44? So on and so forth.
Yeah, I guess that's fine.
Okay, because I had solved these things, like sine theta.
Oh, okay. Yeah, yeah. I think that'd be fine. All right, so let theta be the tan inverse. Take tangent on both sides, or you apply the definition to cancel the inverse. So tangent theta is equal to x. I'm going to put theta here. This is technically x over 1, so opposite adjacent. That's your opposite and adjacent. Then hypotenuse is going to be this. I skipped the Pythagorean theorem. Solving for hypotenuse, you're gonna get x squared plus 1 squared.
Where's the one?
This one. So any number is always over 1. Like 3 divided by 1 is 3. So I can always put a 1 if I want. It's like an invisible one. That allows me to create a ratio. So I'm basically forcing a ratio so I can fill out the triangle.
Is it a plus x plus one or x?
Yeah, plus. Because it's a squared plus b squared equals c squared. So it'll be x squared plus 1 squared square rooted. Right, so if we show our work, you'll have x squared plus 1 squared equal to c squared. So square root both sides would get me here. 1 squared is just a 1. So that's where I got this from. So anyway, they're asking about sine. So sine of tangent inverse of x is equal to sine of theta. This is how we defined it. Sine of theta is opposites over hypotenuse. Okay. Any questions on example 7?
Wait, how'd you do the last
Which one? Here? So we said let theta be defined as tan inverse x, right? So so basically I substituted this for theta. Definition of sine is opposite over hypotenuse. Opposite and hypotenuse. Any other questions on 6.4? Or these problems here? So after this, we move on to logs, cosines, and sines. That's so I'm hoping it's still pretty fresh. But we'll do a couple. Let's see, 6, 5. You guys okay on this page? All right. So I've decided I'm not going to give you a question with 2 triangles. I feel like that might be too much. But 6, 5, yes. But I'm going to ask you, do you have 1, 2, or no triangles? I need to explain why. Okay. So I'm not going to have 2, but you need to know why there's not 2. On this question, they're going to give us 22 degrees for A, 95 degrees for B, C is unknown. Little a, it's 420. And 1116. Point, oh yeah, it's not given to us. This is what I found earlier. B is not given to us. C is also not. Okay. So all we are given is A, B, and little a. So again, you need to know which.
E equals 95?
95. You need to know why we need to use log, sine, or cosine. By looking at this, can you tell which one you're supposed to use?
Yeah.
Yeah, because we have log sine requires, right, an angle and its opposite side. So since we have a pair, right, of lowercase and capital, that's a good sign that, yeah, I should stick with log sign. Okay, but could you use log cosine currently?
No, we can't. Yeah, so it's that.
Yeah, you need to have at least two sides to use log cosines. If you're missing two sides, you cannot do log cosine. And if you want to find angles with log cosine, you need all three sides. And so keep those ideas in mind. When do I use it? I'm not going to tell you what to do. You need to know when to use what. Okay. Can you tell why there's only one triangle here? I mean, you could prove it, right, by solving, or you think about it.
I mean, we can find C by adding, is it adding or subtracting
Subtracting, yeah.
from A and B, right? But I thought it was supposed to be 90 degrees, 195.
Why do you feel it needs to be 90?
It was 180 minus 90 minus.
It's 180 minus whatever the other two are. It doesn't matter what they are. You just subtract these two, and that leftover is going to be C every single time. So this is always true. 180 minus the other two angles will give me the third angle. The numbers don't matter. So capital C is equal to 180 minus 22 minus 95. Okay. Now, if we would have said, you know what, I don't know, there's two triangles or not. Let's pretend you had no idea. I'm sure you can help me. Let's pretend. 180 minus 63 would be the other angle, the other possible angle. If I add 22 and 95 to this one, is that below 180? It's too big, right? So, and an easier way to think about this, since they have given you two angles, they're fixed, right? So it's not going to sweep across. It's already there. So whenever you are given two angles, you should know that there's only one triangle. There's no way another one will appear because you have two corners that are fixed already. You just need that missing corner. Does that make sense? So we don't have to do any of this. If you are given two angles, you have one triangle.
So on the test, like, if you have to prove that, can you just say like by definition?
Yeah, that would be enough for me, or you could show me doing this by solving and adding it to 180, or adding it to the other angles. Okay. Now, if you're given only one angle, that's when you have to test because you have no choice. But you could still have one triangle. So whenever you have a question that only gives you one angle and a bunch of sides, that's when you could have multiple or none or whatever. Anyway, we got C. So let's use law of sines. Little b over sine b, it will be equal to, and I'm going to set this, I want to solve for little b first. So I'm going to set it to the ratio that is complete, right? So little a over sine a, because I have those solutions. Solve for cap or lowercase b. You would have to multiply both sides by sine b. So little b is equal to a sine b over sine A. Plug in everything and we're good. So 420 sine 95 over sine 22. Yeah, 1000, 1116 point what? Cool. Now that we have two sides, you could use log cosines if you wanted to, or you could repeat this process with little c over sine c. So at this point is your call, and you can choose whatever you want to do. I don't care how you solve these, as long as you show your work and do legit math, you'll be fine. No black magic. So let's do log cosine just for fun. Little c in the log cosine formula is going to be, what was it? I think I wrote it down. A squared plus b squared minus 2ab cosine c. So I don't have to worry about fractions or multiplying. I'm just going to plug it in and be done. Okay. So a squared plus b squared minus 2 times a times b times cosine c. So 998.98.
Sorry, question on multiple triangles and you're given a bunch of sides. Do we assume that the sides that are given are over the same side triangle?
If they give you, so the scenario that has multiple triangles would require you to only be given one angle. So they would have to give you a corresponding side and one other side. So you'd have two sides and one angle. So yeah, you could have the other side would have two different sizes.
Could be part of the different triangle.
Yeah,
Okay.
yeah, like you'd have a C1 and a C2. The A would be fixed because that's that one side, right? We have that scenario when we're flipping back and forth. So we'd have one side that's not changing and another side that is. And then two angles would be changing. Yeah, you just plug these numbers in.
For the cosine of C, you put 63 degrees.
Yeah, cosine 63. Okay, I just plugged it in just for fun there. You have it. This earlier, forgot to write it. Yeah. Okay. Any questions on this problem? So as soon as you finish solving a triangle in the exam like this, I'm gonna ask you, probably the next question or the question after, I'm gonna say, okay, what's the area of that triangle in the problem 8 or something? Okay, so that's basically 6. Find the area of the, I guess you can use these super ugly numbers. Previous problem. So A was 420, B was 1116. I'm going to round to the nearest whole number just so it's a little easier to see. It doesn't get too messy. 1117, 999. So we need the 3 sides in order to do this. The formula is supposed to be square root of s times s minus a times s minus b times s minus c. And we said s is 1/2 times the sum of the sides. So let's find s real quick. We'll do it over here, I guess. S is equal to 1/2 times the sum of the sides which is something. It charges guy. We got 1268. Okay. So the area will be 1268 times 1268 minus 420. 1268 minus 117. 1268 minus 999. I'll just close it. Okay. So I got, well, that's kind of huge. Yeah. It is a big triangle, I suppose. It's not crazy. But I do want to double check. I mean, if you look at the sides, right? The sides are pretty big. So the area encompassed by that triangle should be pretty big. Very good. Any questions on area? Area shouldn't be too bad, just a formula, right? Okay. Yeah. So out of time. We just did log cosine recently, so we're not gonna skip that. I think we have time to do another one. Do you have any questions in general? About the review or about some homework stuff, concerns?
Is there gonna be some questions?
I'm gonna try. Some will be, easier than others.
What are the information of the ones that's got like that yellow?
Oh. What, do you remember what?
Ellen?
No. Ellen stuff? No. No logarithms. No graphing, no logarithms.
It's not L, it's like a D or something.
You remember what they were asking in those problems?
It was in 6.5.
The log signs,
Yeah.
I'm gonna give you the triangle and then the angle A, and then A, reuse the. Yeah, that's that.
Yeah, we just did one of those earlier. Log sines and log cosine will be on the exam. So you need to use both to find sine and angles. We did log sine example. We did not do a log cosine. But they'll be similar to what we did on Monday. To those examples. You have a symbol, right? Hold on a second. Let me find. That symbol is just telling you that it's angle A. That's all that means.